In the previous video, we learned how to install and open SecurePose. In this video, we will learn how to use it. First, we will start SecurePose by opening SecurePose start file. Then we will open SecurePose main program file, which is called securepose.ipynp. To open the GUI, we need to click on this Run button. SecurePose GUI has three menu bar items. First, File. Second, Kinematics Extraction. Third, Patient Data Anonymization. On the left side, we can find Project Status Panel. On the right side, we can find Log Panel. And in the bottom, we can find Information Panel. The Information Panel shows the status of the project and tells user about the next steps. The first step to use SecurePose is to either create a new project or load an existing project. To create a new project, click on File menu and then New Project submenu. Enter the project name in Project Name field, and you can select whether you want to mute the videos in the project, and then click on Create Project button. For this video, I am creating a project with name test_01 and videos set as mute. Once a project is created, you can see new values in all three panels. In the project status panel on the left, you can see that the project status for project creation is completed and all other steps are pending. The log panel on the right has the recent entry for the log, and the first entry values are for date and time, followed by log value. The information bar on the bottom shows that the project is created and now it's time to select data. To select data, we will click on File menu, then Select Data submenu. The primary data for this software are videos. By clicking on Select Video button, we can select either one video or multiple videos from the dialog box. Once all videos are loaded, we need to select an output folder for our project. The output folder of a project is a folder where all the output files get stored, including blurred videos and body kinematics. For this video tutorial, I will select desktop as my output folder. We can confirm that on the desktop we do have an output folder for SecurePose test_01 project. Currently this project is empty. Select Data GUI allows user to select metadata associated with the videos for their project. For now, we will not select any metadata. We can notice on the log panel that the project was automatically saved, and that means that we don't have to manually click on Save and Continue button. To find the instructions of the next step, we can check the information panel, and it says the software is ready to perform kinematics extraction. To perform kinematic extraction, we can click on Kinematic Extraction menu. This menu shows all kinematic extraction related steps. Now, if we check Project Status panel on the left, we can find that the next step that is pending is video correction. So I will click on Video Correction submenu. The video correction step ensures that the rotation and resolution of the project videos are proper. If it finds any problem with the orientation and resolution of the video, it will fix it automatically in this step. You can check the status of video correction on the log panel. Once this step is done, the project will be saved automatically. Now, the next step is to perform person detection. For person detection, we will go to Kinematic Extraction menu and then click on Person Detection submenu. This step detects person in the video by detecting their body parts and extracts their body kinematics. If you want to see the results of kinematic extraction in real time, you can check on this checkbox. Depending on your computer's configuration, the frame per second for kinematic extraction can vary. For this video, I am using a computer with NVIDIA GeForce RTX 3070 laptop GPU, and you can see it is using 6.4 gigabytes of GPU memory. Now we can go to the next step, which is to perform person tracking. In the last step, the software extracted key body points of all the people present in the video. But in this step, the software will track all the people in the video and associate a unique ID to these people. To perform person tracking, we will first click on kinematic extraction menu, then we will click on person tracking. Then we will click on person tracking button. Now we can see the results of person tracking and kinematic extraction in the output folder of the project. At this point, we can see two video files, two folders with the name same as the videos, and two other folders for coordinates. These video files are the result of kinematic extraction on the project videos. The coordinates of key body point of all the people in the video are being stored in separate folders in the output folder of the project. Also, the software makes backup of these coordinates before starting each step. Let's open one coordinate file to see what information it has. Each video has a folder with its name for coordinates, and each frame of the video has its own coordinate file. The extension of this file is JSON. In this file, we can find all the information regarding the coordinates and the confidence interval of coordinate extraction for each body point for each person in that given frame. For more information about this JSON file, please refer to SecurePose documentation. The important thing to notice in this file is the person ID. So in raw coordinate folder, all person has ID -1. But in raw coordinates with patient ID folder, all person has their unique ID. Now we will perform the next step, which is to smoothen the tracking. For smoothing tracking, we will click on kinematic extraction menu and then smoothing tracking submenu. Here we get two options to smooth the data, and both the options uses a technique called interpolation. Before we start this operation, let's try to understand what does smoothing kinematics mean and why do we need it. When the software performs kinematic extraction, sometimes it fails to localize the exact location of body points. In that case, the software gives inaccurate coordinates. To find inaccurate coordinates in the data and fix those coordinates, we need to perform this smoothing tracking operation. This operation is divided into two steps. First step is to find the inaccurate coordinates, and second step is to fix those coordinates by using the data of adjacent coordinates. To find inaccurate coordinates, the software look at the confidence interval value of extraction, and if confidence interval value is low, then it marks those coordinates as inaccurate. Now, for the second step, which is to interpolate and fix the erroneous values, the software estimates the missing coordinate values by using the coordinate values of neighboring frames. For example, in frame number 1, let's say the coordinate of nose are at 1, 1, and for second frame the software was unable to recognize the location of nose, but in third frame the software recognized its location as 3, 3 xy coordinate. Now in this scenario the software will perform smoothing tracking, and in the first step the software will localize incorrect coordinate values, which is for nose are in frame number 2, and in second step the software will fit a line for the coordinates of nose, and based on the value of frame number 1 for nose, which was 1, 1, and the values of nose in frame number 3, which were 3, 3, if we fit a line between these two frames, we can find the position of nose as 2, 2 for the frame number 2. This process is called linear interpolation. This process is important for consistent blurring, and the GUI gives two options to the user to perform this operation. The first one is to interpolate only face. This method is fast and recommended for blurring. And another method is to interpolate for whole body. This option is useful for someone who is interested in full body kinematics with interpolated coordinates. In this video, I will perform interpolation only face. Now we can move to the next step, which is to perform patient detection. To perform patient detection, I will click on kinematic extraction menu, then patient detection submenu. This step is important for someone who is only interested in selectively blurring the patient face. Remember, the software is saving all the coordinates files after each step to the output folder of the project. Also, we can export the data into CSV file or Python variables by clicking on File menu and Export Data submenu. The Python variable files saved in raw data folder can be opened using pickle library. The Excel file can be accessed in coordinates folder. Here you can find Excel file for X coordinate, Y coordinate and C confidence interval for each video. The columns in this Excel file are for different body parts, and the rows are for different frames. Now we are ready to perform patient data anonymization. First, we will perform patient face blurring using automatic method. For that, we need to click on patient data anonymization menu and then patient blurring submenu. Here we get several options for performing patient face blurring. The first option allows you to selectively blur the patient face. By default, it is selected to blur all the faces in the video, but by unchecking this checkbox, you can select patient-only face blurring. The second option allows you to perform Gaussian blurring or solid black blurring. In Gaussian blurring, the pixel values on the face are averaged using a Gaussian kernel, while in solid black blurring, all the pixel values corresponding to the face are replaced with a black box. For this video, I will perform face blurring for all the faces with Gaussian blurring enabled. Here is the real-time output of face blurring. Now we can find blurred face videos in the output folder of the project. The software performed pretty well in blurring the faces of all the people in the video. However, if we look closely, we can see that in one particular frame in video 2, there is an extra blurred box. That error can be fixed by using blurring quality improvement option in the software. That features allows users to unblur any selective frame and then re-blur the faces in the videos. We will learn about blurring quality improvement in our next video. For more information about the technical details, please refer to the original paper of SecurePose, which is also in the description, or read the source code of the software. The link to the source code of the software can also be found in the description.